Assalamu alaikum, dear students. We're back with another video lesson. In today's video lesson, we're going to talk about sound intensity and resonance. Let's talk about intensity a little bit. What is the intensity of a sound? For example, when I talk to you, my sound has a sort of certain intensity, of course, that I'm speaking with. What exactly intensity of a sound is? We can say intensity of a sound, that is the time rate of energy transfer through a unit area perpendicular to the direction of wave travel. Basha, as an equation, we can say intensity is equal to, Basha, we can say the time rate, something divided by the time of energy transfer, Basha. So energy per unit time, Basha, that is traveling, or you can say per unit area, or through a unit area that is perpendicular to the direction of wave travel. And imagine if we have a certain area, Basha, how much energy in a certain time passes through this unit area. That is called the intensity of a sound, Basha. And of course, we can see that because previously we've mentioned that sound travel in all the direction here. Got these, of course, sound waves are spreading here. So as the area spreads, for example, gets larger and larger, or in other words, we can say as the sound travel further more and more, the sound intensity spreads more and more, so there will be less energy per unit area. In other words, the intensity of the sound will be less and less. Kata, let's define this one more time. What is the intensity, or what is the definition of an intensity of a sound? We'll say it is the time, or Babylon, the time rate of energy transfer through a unit area perpendicular to the direction of wave travel. There's also another equation for the intensity of sound, and that equation, it is equal to, or intensity, it is equal to what? It is equal to power per unit what? Power per unit area, Basha, per unit area. This is energy divided by the time, and this is the area. What is the SI unit for intensity, Baba? The SI unit for intensity, it is equal to what, Basha? Per unit what? Per unit meter squared, because that would be the unit for area. And of course, we can write W instead of watt, so we could just say watt per meter squared. But what is watt per meter squared equivalent to or equal to here? If you look at this unit here, or from this equation here, we know that energy, it is measured in joule, Basha, and then time measured in second. So let's just write this one here, joule per second, and then divided by unit of area, it is going to be meter squared there. Basha, if we divide this one furthermore, Basha, what would be the unit exactly here? So we can say, or starting from this equation here, Basha, we can say joule per second. We've learned that from the equation of frequency, Gatman, the kata say 1 over period, 1 over period, that is going to be 1 over second, and this is the same as hertz here. So now I can rewrite this equation here. I can say joule times 1 over second divided by meter squared. But this 1 over second now, I can replace that with what? With hertz now. So we can say joule hertz per meter squared there. And then what if I move this second down here? So now we can say joule meter squared second. That is also possible. Now if I break it down furthermore, what is joule equal to? It is a unit of work done, or you can say energy. And joule, it comes from work done. Work done is force times distance. That is going to be force as mass times acceleration here. So let's just break it down further here. Joule is a unit of work done, and work done, it is equal to force times distance. Force, it is mass times acceleration times distance. Basha, instead of joule, we can write kilogram for mass. Basha, for acceleration, that is going to be meter per second squared. For this distance, it is going to be meter. And what is below the fraction? That is meter squared second one, This meter and meter, that would be meter squared to cancel out with this one here. This second goes down, of course, is going to be kilogram second cubic as well. So this is also, we can say, the base unit of watt per meter squared, the base unit of intensity of sound as well. But so now, what is the area of a sound? Now let's emphasize or talk about this one a little bit more here. We said intensity, right, it is equal to power over area as well. But there's one thing you really have to be careful here. In the previous lessons, we said that when we have sound, sound transfers in 3 dimensions. Do you remember that? Said sound transfers in 3 dimensions. That would be x, can say y and z direction as well, right? So once it is expanding here, or consider something the same as a balloon when you inflate that. So the sound expands or travels in all the directions, so in a spherical shape in here. So when we say area, we're talking about the area of a sphere, Baba. Area of what? Area of a sphere. And don't forget, area of a sphere, it is 4 pi r squared. Don't forget, right? Do not confuse this one with the area of circle, Baba, because area of a circle, the pi r squared, then that is not what we're using here. Because a circle would be 2D and sound is going to be a sphere, which is 3-dimensional here. So now we can say the intensity of a sound, the power over 4 pi r squared, Basha. Don't forget this one here. Now, we talked about the intensity or the definition of intensity. Now, that is this equation. So what does the intensity of a sound depends on, Baba? There's also something very important, you know that. Based on this equation, there are two things we can determine. One, yeah, the intensity of a sound that is directly proportional based on this to the power. The larger the power, the larger the intensity of a sound. And based on this, we can also say that the intensity of a sound that is inversely proportional with the area, or to be more specific, we can say it is inversely proportional with the distance or the square of the distance. In other words, if we double the distance, by what factor will the intensity decrease, Baba? We can say the intensity, or if we double the distance, right, the intensity of a sound decreases by a factor of, or you can say decreases 4 times. And the intensity of a sound change by a factor of 1/4. Don't forget this. Now there's more in this case actually. All right. So now there's also one more thing you need to know, Baba. Intensity of a sound, or previously, let me perhaps organize this one and then rewrite it in a different way. We can say intensity of a sound, right? It is directly proportional to the power. We've mentioned that one, yeah. It is also directly proportional to the amplitude squared. And you might wonder, why amplitude squared? If you remember, when we're talking about the relation of energy and amplitude, we said energy is directly proportional to the amplitude squared one, yeah. Now, based on the equation of power now, intensity energy over delta T divided by the area. What is the relation between intensity and energy? Isn't that also directly proportional? If intensity is directly proportional to energy and energy is directly proportional to amplitude squared, can I also say amplitude or intensity is also directly proportional to the amplitude squared? Yes, this is amplitude. Don't forget, Baba. That would be the amplitude of a wave. In other words, the more the bigger the amplitude, that means the more the intensity or the more the power of the wave will be too. Basha, it is directly proportional to the amplitude, and also it is directly proportional to the vibrating area. What is that vibrating area? Vibrating area. Now don't forget this area and the area that we just mentioned here. Let me give you an example. Now if we have, consider this. If I have a guitar string, Basha, that is one example. Let's say this guitar string is stretched on a workbench. It's not connected to the body of a guitar. You just pluck it once, it is going to vibrate one, yeah? Vibrate up and down, and of course it gives you a certain sound. And because, like it's vibrating, so the sound is not that loud, Basha, so this sound, of course, or it just keeps vibrating. Now the same string here, you can connect that to a body of a guitar now. What do you think exactly will happen if you connect this one to a body of a guitar now? Okay, so the same string now, all right? Now if you connect this one to a body of a guitar, let's say there's one string here now. If you connect this one to the body of a guitar and you pluck it once, what do you expect, like the sound or the intensity of this vibration will be? Now, because of course this string is stretching here, so now this string vibrates, correct? Now this vibration, because of this bridge of the guitar and this string here, or like connected with the guitar, the vibration of the string now, it is going to make the body of a guitar to vibrate with it. So as a result, the sound of the guitar is going to sound much louder now. Why is it sounding much louder? Because there is a bigger area that vibrates. Imagine, I always do this, for example. Now tap 2 pens together, all right, with a constant force. Now you can see that this, or the sound of this tapping is not that loud. But if you have a table with you, just tap with the same force, or almost try to do your best so that you can use the same force. Tap with the same force on the table. You will notice that it sounds much louder. Why is that? That is because the second time you tap on a table, or once the string is connected to the guitar body, as soon as this guitar string is vibrating, it makes the whole body of a guitar to vibrate with it. Because it makes the whole body of a guitar to vibrate, Kata, we have a bigger and a larger area that vibrate. But the larger the area, that means more area are in contact with the surface of the guitar. So the whole thing, or the whole area, the whole air particles surrounding the guitar are going to vibrate with it. So it is sounding much louder now. But there's one thing you need to know. Because this string makes the whole body of a guitar to vibrate with it, so the vibration of this string, it is going to die out way sooner. Yani vibration it is going to stop way more quickly compared to this. Because here the energy is going to nowhere around, so it is going to vibrate for a longer time because the energy does not go to the air very efficiently. And Babylon, the energy stays mostly on the string here until it dies out at the end. But later, because the energy of the string goes to the guitar, so now the vibration stops very quickly, which makes the energy of this string, of course, now to go into the air more efficiently. This is why it sounds louder, but the vibration dies out way quicker. This is the vibration area that we're talking about, which is directly proportional to the sound. Yani the larger the area that vibrate, the bigger the sound will be. Basha. So intensity, it is directly proportional to each one of those three that you see here. And we can, of course, add the fourth factor that we said, but if it is the area that this intensity covers, Basha, we can say for the next one here, intensity, it is inversely proportional with the area. But what area, Baba? The area that the sound travels now, Basha, or you can say the distance if you want to. And to be more specific, Gutman, area dakata 4 pi r squared, and you can write intensity, it is inversely proportional with the square of the distance. The further the sound goes, the less and less the intensity of a sound here. Let me give you an example for that. Let's say you and, for example, your classmates are in class one and you talk to one another. You can simply hear one another, Basha. But if there is a person in another room here, while they're talking, do you hear them? Or do they hear you when you're talking normally to your friend or to your classmate? The answer is no. Why is that? Is it because your frequency or the frequency of your sound that is not in the audible range? It is in the audible range, but you just don't hear them. Why not? Because your sound intensity is just not enough, right? So it fades or goes into the air or to the surrounding before it reaches them, or just not enough for them to hear you. That is the sound intensity, Basha Baba. So the further it travel, Basha, the less the intensity. But if a person shouts in the next room, of course, you can hear them now, because once they're shouting, of course, now they have a larger intensity and you can hear them. Sometimes it happens too, for example, when neighbors are fighting, or when a neighbor's fighting, if they're so loud, you can hear them, right? And hopefully that doesn't disturb you from studying or whatever. But don't worry. I think that was nonsense though. All right, Yalla Baba. So remember, intensity, it is directly proportional to the power of the sound, to the amplitude of the wave or the sound, and also to the vibrating area, but it is inversely proportional with what? With the distance squared, Basha. That'll be about the intensity here. There's one more thing, Basha Baba, regarding the distance and the intensity. If they gave you one distance, for example, and they say, how would the intensity change if we increase the distance, double the distance, triple the distance? Then, of course, you could just cross multiply and find whatever you want to. Basha, for example, if the distance becomes double, Basha, by what factor, Gutman, the intensity change? You just write the equation. That is going to be 1 over r squared here. Basha, لذاتي r squared كي باب number كي دابنيو. So 1 over 2 squared, in this case, the intensity changed by a factor 1 over 4. Or you can say the intensity decreases 4 times, Basha. Now, what if we triple the distance, right? Triple the distance, 3 squared, that is going to be 1 over 9. So decreases 9 times. But here's one other thing, Basha. What if they gave you, for example, they said in order for, let's say, the intensity change, Basha, by, let's say, 5 times. In order for the intensity change, Basha, for the intensity to change 5 times. By what factor? By what factor should the distance change? Should the distance change? What do you do in this case, Baba? Just write the equation, right? Don't worry at all. So قطمان intensity is inversely proportional with the r squared one, yeah? نرد الله Baba. If the intensity changed by a factor of 5, Basha, or 5 times, let's say, whichever, once you write the equation, Baba, whichever is given, Basha, so you just make the other one the subject, and then you just do your math, and that's it. Or if I simplify this, once you write the equation, whichever is unknown, make that the subject. All right, if it is not the subject already, then just do the math. Now, if the distance changed by this and that, we were finding the intensity data. So if the intensity changed by 5 times or factor of 5, by what factor should the distance change? Because it is asking for the distance, let's just write it down here. 1 over r squared, you just swap their places here. The distance, right? It is, or distance square should, or it is equal to 1 over the intensity here. Intensity kashman 5, so just write 5 instead. But we want the distance, not the distance square. So in this case, distance, or take the square root for both sides. So in this case, of course, the distance, for this case here, it is equal to what? It is equal to, or you can even write this thing here. Square root of 1 is going to be 1, and this is the square root of 5 kata. The distance should change by a factor of 1 over the square root of 5. Could be any other numbers. You just plug in the numbers and find whichever that is unknown. But there's one more thing here. What if we, for example, says we have a point or 2 points, point A and point B. Basha? This is at this distance we have a certain intensity, of course, and then as the sound traveled to point B, of course, there will be another intensity. So we can call this one intensity 1, intensity 2, and R1. This is R2. Baba? So if you have 2 distances or 2 intensities here, and then they ask you this, then you can use this equation here. Basha, you can use a ratio if you want to. Then we can say intensity 1 over intensity 2. Basha, it is equal to what? It is equal to R2 squared over R1 squared. And where does this come from, Baba? This comes from this equation. If I want to do that, intensity at the power over 4 pi R1 squared, and then this is power over 4 pi R2 squared. These are what it is, but the powers cancel out. These 4 pi's cancel out. What is left in here? 1 over R1 squared, and this is 1 over R2 squared, because these are fractions. We take the reciprocal. So this is going to be the final result. I1 over I2, Basha. That is going to be, this R2 goes up, so these are squared, let me not forget. R2 squared over R1 squared, Basha Baba. So how do you remember this? You can always remember that. This is 2 and 2, and this is 1 and 1. When do we do this, Baba? Whenever we have inverse relations, then these R's and intensities must be opposite to one another. Basha, for example, now, the relation between intensity and distance, it is inversely proportional. Kata, these must be on opposite sides. Same number must be bubbling on opposite sides. Bubbling, that would be same like a cross in here. But if 2 things were direct, Aukati, if, for example, let's say, if the question were about intensity and power, we could have said intensity 1, power 1, yeah? And then over intensity 2, that would be power 2 in this case, because these are direct. So you could have done that one too, Basha, but we don't have it here, so you don't have to worry about this much. Basha. So how do I know it is intensity 1 over 2 or 2 over 1? Because it could be both one, yeah? It could be I2 over I1, Basha. And then in that case, of course, this is 1, so that is going to be 1 squared, and this is R2 squared there. But whether you need to use this or this, that the question determines. But you really have to be careful so that you know the keywords, so you do know which one to use. If it was out of question, you will have to use this format. And I'll tell you how or why we're using this. If you use the other way, of course, you're going to get a wrong answer. That is regarding the intensity, Baba. Yalla day. Let's summarize what we've learned so far. On intensity, it is the time rate of energy flow through a unit area perpendicular to the direction of wave travel. يعني جدة 80 بلين intensity, I think I did not mention or define the second method here. Intensity, it is also equal, then the second definition would be power per unit what? Per unit area, Basha. So all these two definitions been in Uzadi. The SI unit, or you can say the unit of intensity, it is watt per meter squared. The intensity is directly proportional to the power, to the amplitude, to the amplitude squared, of course, also the directly proportional to the vibrating area, but it is inversely proportional to the square of the distance there. And we use I for intensity, don't forget that, Basha. And you might say, Mr. how do I know this I is intensity, not inertia? But don't complicate stuff. If the question is about sound, this I stands for intensity of a sound, Basha. If it is about mechanic motion, rotation, and stuff like that, that is going to be about inertia, so you don't have to worry about that. In a spherical wave, energy propagates equally in all the direction. In this case, Gutman, the power emitted by a source P, it is distributed over a spherical area. Gutman, it is 4 pi r squared, Basha. These are directly proportional to this 3. Basha, it is inversely proportional with the area. More specifically, you can say the distance r. And then you can use this format or this, Basha, depending on what the question is requiring. As the distance from the source increases, the intensity of a sound decreases. However, the power remains constant, but it is distributed over a larger area. So, for example, when a person talks, the power that the sound has, of course, it is constant. That power is fixed, yeah? But as this sound distribute over a larger distance, each portion of a power will be distributed in a different direction. The intensity of a sound will be less as it travel further and further. Remember, I said, and it was in the other session here, said that whenever the question is about echo, Baba, remember two things. When they mention echo, they could be asking for the intensity or the frequency. So let me tell you the detail about each one of these, and you can write a note for yourself because this is very important. So here's the question: says, why the intensity of an echo is less than that of the original sound, Baba? Gutman istaka. Whenever we have a sound here, Masha, or it could be a sound there, and here's a wall, Masha. So this is a sound that is moving, we can say, towards a wall. Okay, now, once this sound is reflected, Baba, let's change this color here. When this sound is reflected, I should have made this a little bit smaller. This would be the echo, right? This is the echo. I think I should have made this way smaller. Echo, Basha. Once they ask for the echo, Baba, they could ask for two things. They could ask for the observed frequency, or they could ask for the intensity of the echo here, or the intensity, Babylon, of the echo that is coming back. But that is, consider this is a bat, or for an object that is moving towards the wall. Basha, Baba. Agad. Regarding the frequency, watch this, the observed frequency, because this observer and the sound are moving or getting closer to one another. Kati, we'll say whenever echo is mentioned, Baba, and if the object is moving towards, Babylon, the sound here, Kati, the observed frequency will be higher than the frequency of the source. Baba. What about the intensity of a sound? This is the question that a lot of students made a mistake in just because they were not focused enough, Baba. Watch this for the intensity, so do not get confused, Baba. But my intensity, it is inversely proportional with the distance one, yeah, with the distance squared. Baba, the more the sound travel, the bigger the distance one, yeah? The more the sound travel, the bigger the distance. What about if it is coming back? When we say distance, yani the total length of the path. Kata, as it is moving, it will lose more and more energy here along the way. Part of it will be absorbed by the wall as well. So even when it is coming back, it still loses energy. Kawata, when we're talking about echo, Baba, and the question is about intensity, Okati, the intensity of the echo will always be less than the intensity of the source. Now, like, how is that? Imagine you're in a cave shouting out loud, or in a large room, and you hear your echo, yes or no? Basha, is the loudness of the echo that you hear, will it ever be as loud as your original sound? The answer is no. Your echo is always less than the Babylon in terms of intensity, the intensity of the echo, it is always less than the intensity of your sound. Why? Because as the sound traveling through the air, Asha, it loses energy. That is part of it. Another part is once it strikes the wall, Basha, the reflection is not perfect. Part of that intensity or that energy of the sound will be absorbed by the wall, Basha. And then other parts will be transmitted through the air, and the energy will be lost through the air. Kata, the intensity of the echo will be less than the intensity of the source, original sound. I'll repeat that. But the frequency of the echo, Baba, frequency, not loudness, will be larger than the frequency of the source. Bas bashartachi, if this babbling of source, it is moving towards the wall, Basha. And this is the question that a lot of students were made a mistake in, and some of them were very confused, and they said even it is wrong. No, Babas, there's nothing wrong with that. They were just mixing. And by the way, hopefully can perhaps maybe we'll show you that maybe in a different time. Basha, Baba, whenever says so the question was like this. For example, a bat is flying towards a wall and emits a sound. Basha, which one of the following is correct? The frequency of the babbling, the observed frequency, it is less than the frequency of the source. That is incorrect, because if it is flying towards Kata, the observed frequency, of course, it is going to be larger than the frequency of the source. There was another question saying the intensity of the sound of the echo, it is larger than the sound of, because the students were confusing frequency and intensity. There was a choice that says the intensity of the echo, it is larger than the intensity of the source. And they were just thinking about the frequency. That is incorrect, Baba, because the intensity of the echo will always be less than the intensity of the source. Why? Because for many reasons. Another reason here, because it travels a distance, right? Baba, when it comes to energy of the echo, it doesn't matter if it is getting closer or away. What it matters is how long does it travel, The more, like even if the sound comes back, that distance will add up to the total distance that is traveled. Kata, the total intensity, and Babylon, the intensity that is back, or the intensity of the echo will be less than the intensity of the source. Kata, why the intensity of the echo is less than the original sound? Because the intensity decreases with increasing the distance, also because of imperfect reflection as well. Kata, because this echo has traveled a lot, so the intensity will be less. Let's answer some of these Wizari questions. And some of them are very important as well, so we'll try to solve as many as we can here. The first one says the time rate, Basha, the time rate at which energy flows through a unit area perpendicular to the direction of wave motion, Basha. So in this case, of course, we just have one definition that says the time rate at which energy flows through a unit area and also perpendicular to the direction of wave motion. That is the intensity, obviously. Basha, intensity of a sound. Which one is it? So that is wave intensity. That will be C here. Okay, now another question here says if the distance from a point source, Basha, of a sound is tripled, watch this, it says by what factor is the sound intensity change? Once again, says if the distance from a point source tripled, yani the distance, it becomes 3 times more. By what factor will the intensity change? Yalla kaka, got my intensity with the distance that is squared one, yeah? Kata 1 over 3 squared, that is going to be 1 over 9. Kata, the intensity will change by a factor of 1 over 9, and that is option A. Zoe Basha. Now, question 3 says, if the distance from a point source of a sound is doubled, by what factor will the sound intensity change? If it is doubled, Baba, 1 over 2 squared, that is going to be 1 over 4, and that is option A, Basha. 4 says, watch this, this is important. To change the sound intensity of a source by a factor of 1 over 3, to change the intensity by this much, don't forget that is the intensity change, not the distance. But the distance from the source must be changed by what factor, Baba? يلا ده قلت معنا equation كله خد بنشرب Baba. 1 over قلت معنا r squared 1, yeah? قلت معنا intensity this time is changed. Kawata, make the r the subject here. R squared, that is inversely proportional with the intensity here. Okay, so once again, r squared, it is inversely with 1 over 3. Baba, tamashaka? We can say this 3 goes up. So r squared, it is directly proportional. We can say with this 3, take the reciprocal of this one. But we want r, we don't want squared. So take the square root for both sides. So this to cancel out. So r will or must change by the r, not r squared. So R must change by the square root of 3. That'll be the answer, so it is going to be option B. I got there. Spherical wave intensity is equal to what, Baba? But man, remember, power over 4 pi r squared, that is option C. Zorbash. Question 6 says, which of the following is the unit of sound intensity? Man, sound intensity, Baba, the say watt per meter squared. 7 says, what is the ratio of sound intensity at a distance of 4 meter to the intensity of sound at a distance of 2 meter? Now, I need you to be careful here, because depending on what you choose, of course, you could easily lose 2 marks, or you can grab or collect 2 marks here. It says, what is the ratio? Basha, you do know that when it says what is the ratio? Ratio means division one, yeah? A fraction here of the sound intensity at a distance of 4 meter. So this is the first distance that is mentioned here, but isn't there a certain intensity here at this distance? You can call it I1, and this is going to be R1, Basha. I1, Basha, the intensity of sound at this distance, R1. Dala 2, Baba, 2 is basically what the division means here, Basha. It's almost like intensity, Basha, of I1, 2, that is going to be divided by, Basha. So I1, 2, 1, yeah, to a distance or to the intensity of sound, to the second intensity, which is going to be this, but we're going to use this as a ratio here. Okay, so I1 over I2. This is how we know it is 1 over 2, Baba. It's not 2 over 1. If you write 2 over 1, that'll be incorrect. Basha, to the sound intensity at a distance of 2 meter now. And we said that because the ratio, Baba, how do I know it is 1 over 2? What is the ratio of the first one that is mentioned, that is I1, to the second one that is mentioned, which is I2? This is how we know it is I1 over I2. You might wonder, how do we know, for example, when will it be I2 over I1? Well, in that case, the question might say something like this. What is the ratio of the sound intensity when it's brought, for example, to a distance of 2 meter from 4 meter, Basha? So when it's brought from a distance, all right, or when it's brought to a distance of 2 meter from a distance of 4 meter there, Basha? So when it's brought from a distance to 2 meter, that is going to be the final distance, which is I2, and yeah, from a distance of 4 meter, that is going to be I1. Hopefully you understood this one. So in this case, it's going to be I2 over I1, and then you could use the other equation. But here, I think it is clear enough, since it says from this intensity to that intensity, so it is I1 over I2, but remember the equation, Gutman, I1, R1 is going to be, this is 1 squared, then this is 2, so the other side, R2 squared. Now, all you have to do, just do this, Baba. So, what is R2 squared? That is 2, but don't forget these are squared, and then divided by 4 squared, so it is going to be 4 over 16, which is going to be 1 over 4. So which one is 1 over 4? That is option A. What happens if you do the other one, Baba? What happens if you write I2 over I1? That is going to be R1 squared over R2 squared one, yeah? So R1 is going to be 4 squared over 2 squared, which is going to be 16 over 4. That is going to be 4. All right, and of course that is going to be incorrect here, so don't do this. All right, this is the correct answer, which is going to be what? Which is going to be option A. All right, that was a very good question. I hope you practice them too here. Now, a few questions regarding this one here. Well, these questions are super easy, so let's solve some of them here. The first question that we have says, what is the intensity of a sound wave? Find what? The intensity of a sound wave. That's what the question is asking. What is the intensity of a sound wave produced by a trumpet at a distance of this much? So this is R. When the power output, so the power is given of the trumpet is 20 watt. Yalla Baba, what is the equation of intensity? Intensity dakata, because we're given power and R over the area, but area kebaba dakata 4 pi R squared in there, Basha. And I really need you to be careful here, because that is the only thing where we use area of a sphere, and then it is going to be 4 pi R squared. Yalla Baba, what is the power? 20 divided by 4 pi times 3.2, but 3.2 square. So you just do the math, you'll get 0.16. It's going to be watt per meter squared, and that is the answer. Let's go to another question. By the way, all the other questions are exactly the same, Basha. So we're just going to give it a try real quick. Basha, agarna, it actually does not even need to solve all of them because these are the same thing. At a maximum level of loudness, the power of 75, let's say 75 pieces orchestra radiated as radiated, like so that whatever it is, 70 watt. What is the intensity? Basha, intensity كأنه doubling of these sound waves to a listener who is sitting 25 meter from the source. Basha. زور باشا يلا بابا intensity دكاتة سدوارة power over 4 pi r squared دنيا power كتسنة it is 70 watt this time divided by 4 pi times 25 squared. Do the math, of course, you'll find the answer, which is going to be 8.91 times 10 to the power negative 3 watt per meter squared. Tell me asana baba. We have this time it says how much sound power does it produce. We have the intensity, all right? We have the distance. Okay, how much sound power does that person generate? يلا بابا قلت مان intensity دكاتة power over 4 pi r squared one, yeah? We want the power, so we could cross multiply. Power دكاتة intensity times 4 pi times r squared. You just plug in the numbers, you'll find the power, and it's going to be this much watt. So it's 2.3 times 10 to the power negative 5 watts. All right, question 21 is also simple, but this time says find the intensity too again. It says a stereo speaker represented by P in the figure on the right, sound waves, whatever, it produces sound waves. Let's move this thing here. Basha, produce sound waves with a power output of 100 watts. What is the intensity of the sound at a point X when it is 10 meter? Got at this point X 10 meter, Baba, is the distance and this is the power, so you're just plugging them into the equation. You'll find the intensity, which is pretty simple in this case here. Now, the next thing that we have is the intensity and frequency determine pitch or determine which sounds are audible. Now, if you remember when we were talking about the audible sound waves, we said audible sound waves are those sounds that are audible, that are hearable by human or by average human. When these sounds of frequencies that range between 20 to 20,000 hertz. But is frequency the only thing? Is frequency of a sound is enough to make every sound in that range to be audible, to be heard? The answer is no. Just like we were mentioning in the other example, consider a person is sitting in the other room, Baba. Now, when you talk to your friend, do you hear the other person or do they hear you? The answer is no. Why is that? Is that not because your sound is not in this range? No, it is in the range. It's just the intensity of your sound is not enough to reach them, Masha. There are two factors that determine which sounds are audible, Baba. The first thing, or the first condition, this sound must have a frequency between 20 to 20,000. That is first. Second, this sound must be intense enough so that it can be heard. Yani kata loudness sound like yan intensity. Okay, let's not go to the loudness yet. Kata the intensity of the sound has to be big enough so that it can be heard by a person. Sometimes if a person is very far, your friend like 100 meter, 200 meter away, if you just talk to them normally, they don't hear you because your intensity is not enough. But once you shouting, calling them out loud, then that is the only case that they can hear you. All right. So then because you just increased your sound. There are two factors that determine which sounds are audible, Baba. These two factors are both frequency and intensity. Now that, of course, made into a question. So you have to be able to answer this too as well. So we've talked about this. Now, frequency of sound waves heard by average human range between 20 to 20,000. Intensity is also a factor that determining which sound waves are audible. That we can make that into a question here, which says, what does the audibility of an average human ear depend on? Well, it depends on both the frequency and the intensity as well. Now, regarding this diagram, Baba, it's never been in Wazari, Basha. I don't think it will be in Wazari, but I'll tell you few ideas just in case if this brought in Wazari, Basha. Now, I want you to look closely at this diagram and see what we have here. So at this x-axis, we have the frequency. These are the audible frequency from 20 to 20,000. And then on y-axis here, we have the intensity of sounds here. The next thing that I need you to look at, you can see that, for example, the center of this diagram or chart here, that is the speech region. The other region is going to be music region. Speech region would be a region, of course, of normal intensity. Music region is louder. And then area of sound is going to be the third region in this diagram. Basha? And then there are some other points here, threshold of hearing and threshold of pain, which we're going to talk about the detail of this diagram right now. Okay, so now continuing with that, of course, we can say sounds of low frequencies, those sounds that are, or that have low frequencies, Baba. What sounds are we talking about? Sounds, like with low frequencies, or sounds that have frequencies that are lower than 50, or sounds that are, we can say, have frequencies that are more than 12,000, Masha, which is this range here. In order to be heard, they must be relatively, or their intensity must be relatively high so that we can hear them. That is the first thing you need to know, Baba. Basha, kata, those sounds with frequencies that are below 50, or those sounds that are above 12,000, in order to be heard, their intensity must be relatively high so that we can hear them. What do you mean by relatively high? You can see that if you look at the intensity here, it has to be somewhere here. And for this one too, well, like their intensity must be, or could be something even larger than that here. So their intensity has to be large enough so that we can hear them. That is one thing you need to know. Now, we can see that sounds in the middle of the spectrum here, right? That is called speech region, and you can see that these are sounds here that can be heard even if the intensity is low. Because when you talk to your friend, if they're sitting right next to you, you don't have to shout loud, like out loud, or let's say shout on them just so that they can hear you. No, you just talk normally, even if the intensity of sound is not that much. Even if you whisper, they can still hear you, but if they are very close to you. Basha, and if speech region, that would be when you're sitting in class and somebody talks and you can hear them, yeah? These are called speech region. So they don't have to be, or their intensity does not have to be that much to be heard. So they can be heard even if the intensity is low. Basha, that is another thing regarding this point here. Now, the next points are something very important here. And that is point number 6, we can say, and 8 as well. What is point number 6, Baba? We can say the loudest sound, Basha. Or we can say, first of all, actually, let's talk about the softest sound. All right. So the softest sound that can be heard by average human, Basha, ear, all right, that is going to be about, or it is 1,000, that has a frequency of about 1,000, Basha, and an intensity of about 1 times 10 to the power negative 12. This is the softest sound that can be heard, but remember, this is by an average human, babbling an average human, Basha, average human ear. Okay, so average human ear, right? What is the softest sound that is heard by average human, let's say, ear? It is a sound that has a frequency of 1,000 and an intensity of 1 times 10 to the power negative 12, Basha, and we call this one the threshold of hearing, Basha. What do you mean by the threshold of hearing, Baba? It is almost like the turning point of hearing and not hearing. The point between hearing and no hearing. If the sound, Basha, if the sound intensity from this point and higher, we're going to hear it, Basha. If it is below this intensity, we're not going to hear it, Basha. This is what we call a threshold of hearing, which is right the barrier between hearing and no hearing there, Basha. This is why we call the threshold of hearing. But look, remember, we said this is by average human being, Basha. There are some exceptions. There are some other humans that can hear sounds even at intensities that are lower than that, Basha. You can call them, I don't know, superhumans. Actually, no. Sometimes they say Jezor Tija. That's because of that. They can hear, like better than other people. So what are those humans, or what frequency, Baba? There are, like for example, for other people, you can say those exceptions here, they can hear, Basha, sounds even at frequency, even at intensities lower than this much. But at what frequency, Baba? At frequencies that are about 3,300 hertz, Basha. Let me remind you these 2 points again. Gutman, the softest sound that is heard by average human ear, it is a sound that has a frequency of 1,000, an intensity of 1 times 10 to the power negative 12. That is the intensity. But there are some other people who can hear sounds even with lower intensity. But at what frequency do they hear these sounds? At a frequency of about 3,300 hertz. Basha? That is the softest sound we can say. We said that we talked about the softest sound that can be heard. Yeah? What about the loudest sound, Baba? The loudest sound that human ear can tolerate without getting pain. Yani the highest or the loudest sound that you can hear without getting pain in your ear, it is a sound with an intensity of just 1 watt per meter squared, or you can say 1 times 10 to the power negative, 10 to the power 0, but you know that 10 to the power 0, that means just 1. So we can say the loudest sound that human ear, average of course, human ear can tolerate has an intensity of just 1. For that one, of course, we don't have a specific frequency, we just have the intensity. Kawata, what is important here, you need to know, Baba, is the threshold of hearing, Basha. That is the point where you start to hear. Man intensity kitanda, it is 1 times 10 to the power negative 12. Frequency kashi, it is about 1000, Basha. What about the loudest sound that a human ear can tolerate without getting pain? That is called threshold of pain and has an intensity of about 1 times 10 to the power negative 0, or you could just say 1 watt per meter squared. Basha. There are more things actually. What happens if there is a sound that has an intensity larger than this, Baba? If the intensity of a sound is larger than that, larger than the threshold of hearing, or threshold of pain actually, threshold of pain, what happens if the intensity is larger? Then that causes an immediate damage to your ear, even if pain is not felt. There will be a damage in the ear system, Babylon, or in your ears, even if you don't suffer or if you don't feel any pain in your ear. There's another thing that you need to be careful with. That is, prolonged exposure of sound can also damage your hearing. What exactly do you mean by prolonged exposure? Baba, there are some people who listen to music daily for hours. Yeah? In that case, even if the volume of the music, even if it is low, but because you're listening for too long every day, that is called prolonged exposure. And you're exposed, you hear the sound for too long. That sound will damage your ears even if the volume is not loud. That is called prolonged exposure. And this is the reason why musicians wear an earplug, because they deal with musical instruments and practice and then do all that. So their ear, they wear an earplug so that they can protect their ears. Basha? So this is what prolonged exposure do, even though I believe, and it is a fact as well, the only thing that will not affect your hearing if you listen, even if it is too long, that'll be listening to Quran, which I recommend you hearing that whenever possible, or at least listen to that. That'll be a healing, mental healing, physical healing, every kind. I believe in that. All right, Yalla Baba, going back to this one here. Gutman, the softest sound, all right, that can be heard by average human ear. The Khutana underline Kababa. Basha, Gutman, the softest sound. Basha, let's change this color. The softest sound that can be heard by an average human, this average occurs at a frequency of about 1000 and an intensity of 1 times 10 to the power negative 1210 watt per meter squared. Man, some humans can hear slightly softer sounds at what frequency? 3300, we can say. The loudest sound that human ear can tolerate without getting pain have an intensity of about just 1 watt per meter squared. And then exposure to sounds, like prolonged exposure, Baba, before that, exposure to sounds above the threshold of pain can cause immediate damage to the ear, even if no pain is felt. 10, we said prolonged exposure to sound, even if low intensity, can also still damage the ear. And this is, of course, the last thing that we have. Why many musicians wear earplug during their performance, Baba? Because prolonged exposure to sound can damage their ear, so they're trying to protect their ears so that it won't get damaged. Now, the last two things to remember here, my threshold of hearing, Baba, it is the softest sound that can be heard by average human being, has a frequency of 1000 and intensity of 1 times 10 to the power negative 12 watt per meter squared. Basha, what about threshold of pain? Good man, it is the loudest sound that human ear can tolerate without getting pain. Of course, have an intensity of just 1 watt per meter squared. Basha, these are regarding the intensity of a sound here. Okay, the next thing that we have, it is relative intensity. It is measured in decibel. All right, so the intensity of a wave. Now, what is exactly relative intensity? What is exactly relative intensity? How about, do you remember when we were talking about pitch? But man, the frequency of a source determines the pitch one, yeah. The higher the frequency, the higher the pitch, the lower the frequency, the lower the pitch one, yeah. Now, we have something similar to that regarding intensity of sound and loudness. Basha, Kawata, we can say the intensity of a sound, it is approximately and almost determines the loudness of a sound, but the relation is not directly proportional. So what is it exactly? The relation of that, or you can say human perception of loudness, it is rather logarithmic. So first of all, what is relative sound intensity, Baba? It is represented by letter B, Basha, that is called relative what? Relative sound intensity. Basha, relative sound intensity. That is human perception. You can say how loud we hear the sound. That is what is, or the loudness that is received by a person, that is called relative sound intensity. And the reason why we call it relative, because it is, like different from one person to another, from one distance to another. So it depends, Basha. But we can say the intensity almost is determining how loud the sound is perceived, Basha. But these are not directly proportional. So what is the relation between relative sound intensity, Basha, and intensity, Baba? This is called relative sound intensity. With intensity, so the relation is a logarithmic function. What is it? It is a logarithmic function. Kata relation beni relative sound intensity, again intensity, it is a logarithmic function. And it's not direct, it is not inverse, Basha. It is rather than, it is a logarithmic function. Basha, yani relation log da Baba, so it is not direct. So this is exactly what it is. Kata, we can say human perception follows a logarithmic function when it comes to human babbling, the loudness, and human loudness with the perception of loudness follows a logarithmic function. That would be the relation between relative sound intensity and the sound intensity. Basha, that is called again relative sound intensity. Basha, what is the unit of relative sound intensity, Baba? Because if we write the equation for that, let me write the equation now. Gutman, that was the relation, but the equation is, we'll say 10 log of, Basha, I over what? Over I naught. What is this I naught, Baba? That is called relative, I naught, that will be the intensity of sound. Intensity of sound at threshold of hearing. At what? Threshold of what? Threshold of hearing. And what is the intensity of sound of threshold of hearing, Baba? But man, it is 1 times 10 to the power negative 12 watt per meter squared. Basha. So this is the relative sound intensity, 10 log of I. That would be intensity of a specific sound and a certain sound. Basha? Intensity of a certain sound. Certain sound divided by the intensity of sound at the threshold of hearing. And now we can use this, of course, as a definition of relative sound intensity. What is the relative sound intensity here, the definition? We can say it is, Basha, it is the ratio of what? Ratio of sound intensity of a, let's say, the intensity of a specific sound to the intensity of a sound at the threshold of hearing. That is the definition of relative sound intensity. Basha, what is the unit of relative sound intensity, Baba? Good man, later intensity kada kata watt per meter squared. When this intensity is also watt per meter squared. Basha, so these two cancel out. Kata, there's no unit for we can say relative sound intensity. But of course, in physics, you have to use something to describe, to recognize one, yeah? When you say, for example, 10, 100, 90, or 200, whatever one, yeah? So how do we know whether if it is 200 kilometer, meter, second, hours, whatever one, yeah? We'll have to use something to describe, so we'll use something called decibel. Basha, got a decibel. It is a dimensionless unit, just like radian, huh? If you remember chapter 1, Baba, we used radian for angular displacement. There, we'll use decibel. It is the dimensionless, but we'll use this to describe the relative sound intensity. Sometimes, instead of calling it relative sound intensity, that long name, we'll just call that one the decibel level. Basha. Otherwise, decibel, it is a unit that describes, Babylon, the relative sound intensity. That is regarding that. Basha. Now let's perhaps maybe answer a few Zari questions, and then after that we'll solve some other questions. My equation, okay, Baba, 10 log of I, intensity of a certain sound over the intensity of sound, the threshold of hearing, Basha. And then it is unitless, Basha, but we'll use decibel to describe the relative sound intensity. Got that decibel level, it is a dimensionless unit used to describe the relative sound intensity. Let's go through these questions or points real quick. On the intensity of a sound wave approximately determines its perceived loudness, but the loudness is not directly proportional to intensity. Human perception of loudness follows a logarithmic function, Baba. That's been in Wuzari, Basha. So human perception of loudness, the loudness that we receive, we hear, it is not directly proportional to intensity, but it is a following logarithmic function. Kata Dalan B, it is directly proportional to log of I over I naught here. The measure of the loudness, sometimes it is referred to as a decibel level as well. Basha, sometimes instead of calling it relative intensity, we'll just call it decibel level. What is the definition of relative sound intensity? We'll say it is the ratio of the intensity of a given sound to the intensity at the threshold of hearing. Again, it is a unitless, but we'll use decibel to describe that. It is the dimensionless unit that describes the relative intensity of sound. Mano equation kana baba. I over I naught. I naught is good man. It is the threshold of Babylon intensive sound, the threshold of hearing. Basha. Remember this. I believe this been in Nuzari, if I'm not mistaken, if I remember correctly. Yalla Baba, let's answer a few questions, and then after that we'll go to some other questions. The question says the loudest sound that human ear can tolerate. How can I go to the loudest that human ear can tolerate, Baba? That is going to be what? Gutman, this is the threshold of pain, Winya. Is going to be 1 watt per meter squared. The value of, this one here, the value of I naught in this equation, Basha, what is it equal to? That is equal to, Gutman, 1 times 10 to the power negative 12 watt per meter squared. The range of audibility of an average human ear depends on what, Baba? Is it only depends on the intensity? No. Is it only depends on the frequency? No. It depends both on the intensity and frequency as well. All right, the next thing, I believe most of the other questions are repeated now. Dimensionless unit that describes relative sound intensity. Dimensionless describes relative intensity. Good mind of this. Decibel, Baba. I got DB10. And this is, you can say that it is the same question. Basha. Let's solve a question or two, maybe. We have a study tip says the threshold of hearing, Basha, it is, or whenever says threshold of hearing, Baba, that is the minimum sound intensity. And Gutman value that it is 1 times 10 to the power negative 12. What if it says the maximum, or let's say threshold of pain, Basha? That would be the loudest sound or the loudest intensity that human can hear without getting pain, and has an intensity of just 1 times 1 watt per meter squared. What if it says, what is the minimum relative intensity or the decibel level, Baba? So now the question has changed. What is the softest, or what is the minimum relative sound intensity or the decibel level that a human can hear? That is 1 decibel, 0 decibel, Basha. That is 0 decibel. This is we can say the minimum decibel level we can ever hear, Basha. What is the loudest Babylon decibel level that we can hear, Basha, without getting pain? That is going to be 120 decibel. But where does these number come from? Let's answer these questions, Basha. So for example, the question might say, what is the relative sound intensity at threshold of hearing, Basha? What is relative sound intensity يعني B but at threshold of hearing, Basha? Threshold of hearing بابا intensity كيتسمى threshold of hearing, it is 1 times 10 to the power negative 12. يلا بابا equation كمان لو بنسوي قلت مان B relative sound intensity and decibel level دكاتة 10 log of باشا I over I naught. أو مان هي باشا I naught, what is I naught equal to? So let's redo this one. B دكاتة 10 log of باشا قلت مان equation كده let's intensity يا شبابا threshold of hearing يعني 1 times 10 to the power negative 12. Good one, okay, see is not a problem. Divided by threshold of hearing, Baba, that is also 1 times 10 to the power negative 12. These two cancel out, and we can say log of 10, basically 10, Baba. Log of 10, if you press this one into a calculator here, now sorry, that is going to be 1, so log of 1 is going to be 0. So now the relative sound intensity, 10 times 0 is going to be 0, but 0 what? 0 decibel level, right? The threshold, Baba, and the relative sound intensity at threshold of hearing, at a 0 decibel level. Basha, what is the relative sound intensity at the threshold of pain? B at threshold of pain, Baba. With man I threshold of pain tanda, it is just 1 watt. Intensity at the threshold of pain, it is 1 watt per meter squared. Allah Baba. Let's do the equation again. So B dakata, relative sound intensity, 10 log of Ch I over I naught. One yeah. Dubareko 10 log of قلت مان threshold of pain when كاتا intensity كمان سنة is just 1. Threshold of hearing قلت مان 10 to the power negative 12. You don't have to write 1. Okay, now you don't have to worry about this. Just press these numbers into a calculator, you'll get the answer. But first, do this part, and then you could say log of this part, then multiply by 10. So of course, once you do this, you'll get 120 decibel, and that's it. And if you want to do that mentally, this 12 or negative 12 goes to the top, becomes positive 12, Basha. Now we can say log of this 10 here, that it becomes 1, Basha, the log of all that. And then this 12 times 10 is going to be 120 decibel, and that'll be it. Basha, these are threshold of hearing, and this is threshold of pain. These are the numbers. What if it is at any other numbers, Yani? So for example, what is the relative sound intensity, Basha, if the intensity of sound that is 10 to the power negative 3 watt per meter squared, yeah? Any random number. We'll do the same thing with my relative sound intensity. They got the 10 log of I over I naught. Yeah? Do bariko 10 log of, right? I command send 10 to the power negative 3, I naught 10 to the power negative 12. Once again, use a calculator, Baba. All right, what is it equal to? It is going to or equal to 90 decibel. 90 what? Decibel. This is relative sound intensity. Basha, can we do the reverse? What do we mean by the reverse? If I have the relative sound intensity, can I find the intensity of a sound at that, for example, relative sound intensity? Let's reverse this question. If the decibel level, Basha, it is 90 decibel, what is the intensity of sound? Basha? What is the intensity of sound? Basha, write the equation, Baba. The line B dakata, 10 log of I over I naught. We already know what is I naught one, yeah? We want this I right here. Yalla Baba. Good man, later 10 man here. Relative sound daka 90 equal to 10 log of I over I naught. I'm not going to replace this one for now. Yalla Baba. Can I divide both sides by 10 by 10? Yes. This side is going to be 9. What is left on the other side? Log of I over I naught. One, yeah? You agree, one, yeah? Yalla Baba. Let's see. How do we get rid of this, Baba? Of course, you can use the lin for both sides and all that and do this and that. There are procedures, but I really don't want you to do this. All you have to do is this, Baba, because these are supposed to be base 10, all right? So just cross out this log and make whatever this number add a base of 10 for this number. That's the only thing you need to do. Basha? I'll repeat. What do? Cross out the log and just add a base of 10 for whatever the number that is at that side here. So now, what is the number now? Or what would it become now? It becomes 10 to the power 9. This is what it becomes. It is equal to I over I naught, Basha. So what is I naught now? You could replace the number now, Basha. I naught that is 10 to the power negative 12, right? We just, like, this is threshold of hearing one, yeah? So we just write the number back. Now, after you cross multiply, intensity, the kata, 10 to the power 9, that is this, multiplied by 10 to the power negative 12. And you do know that these are both have the same base one, yeah? Kata, you just add or subtract depending on what you have. So positive 9 and negative 12 is going to be negative 3. So this is the intensive sound. Because it is intensity, it is watt per meter squared, and that is the answer you need to know. Now let's go back to the malzama or the pamphlet. Now these are the examples that I did, all of them here. And by the way, Baba, there's a fast way you can do that, right? But I really don't think you need this fast way here. Even though this fast way might, of course, it will make it easy. But regarding the steps you've done, I believe there's nothing complicated in there. So do the long way, all right? It's way safer and better. So I really don't want you to use this one. But of course, I write them just for those who prefer this. Asha, you can use that as well. How do you do that, Bab? If you want to change the intensity to relative sound, Okati, all they have to do is write this equation. That would be 12 plus the power of the 10, and then times 10. That would be it. For example, I get intensity ka power negative 5, Baba. Then I'm plus after relative sound intensity, 12 plus minus 5. That is going to be 7 one, yeah? 7 times 10, 70. That's easy enough, but I don't think still. But if you want to do the reverse, intensity, you'll say intensity the 10 power, they divide by 10 minus 12. For example, we have a relative sound intensity which is 80 decibel. In order to do that, Baba, 80 divided by 10, that is going to be 8 one, yeah? 8 minus 12, that is going to be negative 4, so it's going to be 10 to the power negative 4 watt per meter squared. That is also possible. Asha? I believe we're going to leave this one for another time. Yes, because we don't want to extend this one for too long. Yalla Baba. I think next time we're going to start at this point here. That'll be the end for this session. Till next one, keep practicing and I'll see you soon, inshallah. Assalamu alaikum wa rahmatullah.